This is our metadata watermarking project. The objective of our project is to develop advanced watermarking technology specifically designed for video streams. One of the key objectives is to guarantee that the watermarks remain imperceptible to viewers. Another one is the inclusion of watermarks does not slow down the delivery of the video content. What we did so far is that we completed a script that can embed metadata watermarking within video content for Dash. We completed a script that can validate the presence of metadata within the video content for Dash. We set up a mock live stream to exhibit how our system works. We established an EC2 instance that can perform our metadata watermarking solution within the cloud. We utilized Jenkins pipelines to set up a front end to interface with our system. Me and James are working on HLS inclusion. HLS is basically a tool used to deliver media content over the internet by segmenting the content into smaller files and then deliver to the viewer's devices. How this code works is that it creates a manifest which contains all the media content's data, and it acts as a roadmap for video players. The manifest includes 3 different types of playlists: the master playlist, the variant playlist, and the media playlist. The master playlist provides an overview of available video qualities and references the variant playlist. The variant playlist represents different video qualities, while the media playlist contains the actual video segments. The importance of multiple video quality is that it offers an adaptive streaming where the player dynamically adjusts the video quality based on network conditions. It's to cater to diverse viewer needs and device capabilities.
Streams, I'll be going over both the HLS portion and the remaining challenges. Here you can see the code for embedding a UUID into the header of an HLS manifest. And next you can see we have code for correctly setting the path from the manifest to the stream playlist, and from the stream playlist to the designated data segments. And here you can see that Charles and I were working on validating the presence of a UUID, and we start by reading the manifest labeled output.m3u8 and then find where the line begins that says hashtag ext-x-define, which is a line that contains the UUID that we embedded within the manifest. And then it prints that line to the terminal so that we can read it. So some of the remaining challenges we have to work on is implementing a Mongo database, making the Dash script more generic, revising the HLS script, and making the HLS script modular, as well as completing the documentation.
Okay, so this is the coding portion of the project, and because of the time constraint, I'm just simply going to be giving a general overview of each file and its main functionality. If the professor or the TAs have any questions, feel free to reach out to me via Canvas or email, whatever your preference for communication is. So here we have our first file here, which is main.py, and basically this is the main file that calls all the other helper files. And we're trying to be modular here, and because of the modularity of it, we want to abstract the logic and complexity to the other files. And so here we have a few arguments, so -o and -u. -o is the output folder that we create with the manifest inside of it, and then here we have the manifest URL. And so this manifest URL is exactly what it says. It's the URL to the exact manifest that we're trying to grab the content from. And so basically, like I said, this main here just, first of all, it instantiates a dictionary value that we then populate with the content from the parsed manifest. But then it also, of course, calls all of the other helper files here, which do all of the logic. So I'll just give a quick scroll here. Okay, cool. Okay, so here we have media transfer, and this file here is responsible for transferring the files to and from the cloud, specifically the CDN in the S3 bucket, as well as any URL link that we get. We're basically extracting the content into a folder from the internet, and then we also check the status codes to make sure everything's okay. Um, and then here, of course, is where we're inserting into a S3. Okay, so this is the extract media. This is the actual meat and potatoes, per se, of our application here, of our script. So this is what actually takes the manifest content that we parse and stores it into the dictionary value that you saw earlier in main. And so this is what actually grabs all the content from it and stores it there. So I'll go slow here, just slowly scroll. And so here we have some helper functions for handling different formats. So here we have the compact format.
Hello, my name is Manuel Castro, and I'll be trying to do this demo as fast as possible, so we don't have enough time. Okay, now let's go to the AWS so we see the several things that we have here in our instance. First, here we have the EC2 instance we are right now using, and now let me log in here in AWS in the Jenkins with our password. Okay, so the first thing we're gonna do is we're gonna go here, we're gonna go there one VOD video that we are ingesting, right? And then let's preview this video. It's gonna be a very fast video. It's gonna be a 30-second video. As you can see here, the video is ingesting as an hour. The first thing we're gonna do is we're gonna get here the URL, right? And then we're gonna come to our Jenkins, and then we're gonna run the main script. That's gonna be the first step. And then in the main script, we're gonna put here, we're gonna select what's gonna be our output directory. This is gonna be the directory. We're gonna save all the information of what we're doing, right? And then we're gonna put our link here. I'm gonna paste the link. And then here this gonna connect using SSH with our EC2, and then you're gonna start running all the code inside, also setting out all the environment inside the EC2 machine. And then you can see this is happening here in real time, so we can have access to all the logs and all the process that is being printed to the console in this case. This video is gonna be like how to very fast, so what happened here is gonna be the following. We're gonna be getting the manifest, and then we're gonna try to parse the manifest. After that, we're gonna start to extracting all the video segments and the audio segment, and we will apply to every init MP4 for the video from the audio. We will apply the CPRT box with one UID that's gonna be unique, that's gonna be inserted here, as you can see here. And then here we're gonna at the end we're gonna be able to, now it's finished, I can show you here the pipeline. So at the end here, we're gonna be showing how was the total time that takes to apply our UID, and then after we apply the UID inside the CPRT board, inside the NEMP4, we're gonna validate that the information is there to be sure, right? And then the next step is going to be to clear to deleting whatever resources we are using, whatever temporary folder, whatever thing we are using. We're going to see now we're going to do the second step that's going to be the validation. What's going to be happening here? We're going to try to validate, because we are putting this one in S3 bucket, and after that we are streaming that we're using a CDN, right? We're going to try to validate that we are able to find over any URL our CPRT with the UID inside. So, and then what we're gonna do here, in this case, we're gonna do the two cases, the case that we have a signal that have the CPRT, and the case that we have a signal that doesn't have the CPRT. So in this case, we're gonna use none, that means we're gonna use the URL of the last signal we process, right? And then when I go run here, this is gonna go again to the EC2 machine, it's gonna connect to the EC2 machine, and then it's gonna try to validate if the file inside the CPRT box also. And if we come here, we can see the output, and then we can see that we connect, we don't load the ini MP4. That is the only file that we need to do this one, right? And then with that MP5, we validate that success that belong to us, and this is the time it takes in milliseconds to do this process. You see, it's very, very, very fast. And now we're gonna get, for example, gonna go to BeMoving, and let me go, for example, a test. In this case, well, let's get a test signal from BeMoving. This is another video that doesn't belong to us. We're gonna copy the URL, and then we're gonna try to validate this URL with our code. And then what's gonna happen is supposed to not be able to validate the code, because this signal doesn't belong to us. So yeah, we come here and we check the output or our thing. We see that in this case here, okay, we come here and we can see that the no UID has been found. That means we don't have a CPRT inside that signal that belongs to us. Okay, I think that is all for our presentation.